Okay, so we're asked to evaluate the integral from -1 to 2 of the function 3x squared. So to do this, we want to find something called the antiderivative. Anytime you want to evaluate an integral, you can do that by finding the antiderivative. And an antiderivative just means something whose derivative turns back into your function. So we got to think, what function would have a derivative equal 3x squared? So we just need to work backwards with those power rules of derivatives. So the derivative of, let's say, x squared, the derivative is 2x to the first, right? Because the power rule says the power comes down and multiplies, and then the power gets reduced by 1. So if we're taking an antiderivative, then we want to consider a bigger power. The antiderivative of 3x squared, it has to have an x to the third in it somehow. Okay, and let's see what the derivative of x to the third is, because maybe we're done. Maybe we have everything we need. If you take a derivative of x to the third, the 3 comes down and multiplies, and then the power gets reduced by 1. Oh, that's what we wanted. So we have our antiderivative right here. The derivative of x to the third is 3x squared. Therefore, this is the antiderivative. Okay, so we've got our antiderivative. Now we just need to plug in the limits of integration. So that's the notation that I was taught. I think there might be other notation out there, but we want to plug in 2 first, and then subtract what happens when you plug in 1. So 2 to the third is 8. -1 to the third is still -1. So our answer here is 9.